second part of the Unit 3 review. So I'm going to pick it up at problem number 21. Now, problem number 21 is actually a part of the lesson that I did not choose to do, so we can get into the review, because the lesson I didn't choose to do was finding the derivatives of the exponential functions or logarithmic functions. So if you go to the formula sheet that you'll have for the test, you'll notice kind of near the very end, the last four are derivatives of your natural exponential function, your natural logarithmic function, and then your general exponential function and your general log function. So the one we're doing here in 21 is actually going to be the general exponential function. All right, I'll write down that formula. So it's the derivative. Get the writing. There we go. The derivative, bear with me, almost there. There we go. So the derivative of the exponential function, so where b is your base, is going to be b to the x, okay, times the derivative of, I guess I should write this as g of x, whatever is in the exponent, times the natural log of b. All right? So again, the idea here is that you're just going to follow the process from the formula sheet. So in this case, I'm doing the derivative of 3 to the x power. So I'm going to copy down 3 to the power of x times, now I have to do the derivative, so d dx of x, right? Because x is in my numerator. So whatever's in, not numerator, sorry, in the exponent, whatever's in the exponent, that's what you're going to be taking the derivative of. So in this case, it's fairly simple because the derivative of x is just going to be 1 times the natural log of our base 3. So the answer here is going to be 3 to the x times 1 times the natural log of 3. And if you're looking for your answer, you'll find this one, which is B. All right, so again, I know I didn't do a lesson on this, but my hope is that since you've been practicing derivatives for weeks now, that you can follow the formula to find the derivative of an exponential equation. Okay, let's do number 22. So we're going to find the derivative of x times the sine of x, okay? Now this is two functions multiplied together, so I'm going to be using the product rule, which says that to do this, I am going to be finding the derivative of the first one times the original second plus the derivative of the second function times the original first. Okay, again, if you need that formula is on your formula sheet where it says the product rule. Okay, so the derivative of x is just 1. That's 1 times the sine of x plus the derivative of the sine of x is cosine of x times x. So the answer here is going to be sine of x plus x times the cosine of x. So I'm looking for this in my answers, and I find it in B. 23. Now 23 says that we have two differentiable functions, f and g. They're shown in those graphs. And we're told that p of x is the product of the two of those. So we want to find which of the following is true if I want to look at p prime of negative 2. So let's just do a little work on p prime of x. So that's the derivative of f of x times the original second, right? This is the product rule again, times the derivative of the second times the original first. So p prime of x would be f prime of x times g of x plus g prime of x times f of x, and they want us to plug in negative 2 for x in this derivative. So f prime of negative 2 times g of negative 2 plus g prime of negative 2 times f of negative 2. Now, the ones that are the simplest to do are just the ones that are the regular functions, right? You'll notice we have the curves here. So f of negative 2 is right there, and g of negative 2 is down here. You can estimate that if you want. So that's easy enough to plug in. So f of negative 2 is going to end up being 0. All right, I'll figure out what those are going to be. And then g of negative 2, I'm going to just estimate as negative 5. Again, doesn't matter, your choice, as long as it's negative. Now, here's I think the most challenging part and kind of the key thing I want to focus on. To find the x value of negative 2 at each of these derivatives, remember the way you can do this is to find the slope of the line that is tangent at that point. So the slope right there and the slope right here. So again, you're just estimating, but that's a pretty steep slope. So let's say the estimate for f prime at negative 2 is going to be positive 6. Doesn't matter. Make up whatever you want. And this one's a little less steep, so I'm going to say positive 4 for g prime of negative 2. Now, you should notice that when I go to finish this problem, that one of these has a multiplication of 0. So I know that's going to be gone. That's just going to be 0. And this is going to be, in my approximation, negative 30. So I'm looking for an answer that's negative 30 or around there. If you look at all your answer choices, you'll notice it doesn't even actually give you a value because they know you have to estimate. So I'm looking for a value that is saying it's negative. And the one that says that p prime of negative 2 is a negative number is A. Less than 0 is negative. Okay? All right, number 24. Another question where I'm going to ask you to kind of learn how to do this as we're reviewing. We have the natural logarithmic exponential function here, the e, right, a base of e. So I will be using one of my bottom 4 here, the natural exponential function. I'll write it down so you can see it. So we have d dx of e to the g of x power, so whatever that is equal to e to the g of x power times the derivative of g of x. All right? So I'm going to use the product rule first, which says that f prime of x is going to be the derivative of e to the 2x. So watch how I do this. So you copy down e to the 2x, and then you multiply that by the derivative of what's in the exponent. And what's in the exponent is 2x. The derivative of that 2x is positive 2, times the original second, which is x cubed plus 1, plus derivative of the second one, which is 3x squared plus 0, times the original first, e to the 2x power. Okay, so now you can clean it up if you want, but ultimately we're going to just be plugging in that x value of 2. So I'm going to plug that in now. So it's e to the 2 times 2 power times 2 times 2 cubed plus 1 plus 3 times 2 squared times e to the 2 times 2 power. So that's e to the 4th power. 2 cubed is 8. 8 plus 1 is 9. So 2 times 9 plus 3 times 4 times e to the 4th power. So watch what happens here. You get 18 e to the 4th power plus 12 e to the 4th power. And kind of similar to how you learned in middle school that if you have a variable, all right, the same variable, like I'll do a little sidebar here. Like if you were to have 3x cubed plus 6x cubed, this would be 9x cubed. So you add the coefficients, but leave the exponent the same. Same idea here. So 18 plus 12 is 30. So this is going to be 30e to the 4th power, or letter T. All right, so that's 24. Let's go to 25. Now, 25, I want to apologize. I actually already did 25. That's my bad. When I was making these, a lot of these questions, kind of count for different topics. So I actually did number 25. So when you get to 25, if you want to see it, they see number 3. Okay, number 3 will have all the work that I did in the key. And if you want to watch the video from part 1, find number 3. It's the same problem. Okay, 26. 26 says we have a linear function, f of x, and a piecewise linear function, g of x. And we want to look at h of x being the multiplication of those two. So to find the derivative of h of x, this is using my product rule again, so notice that's pretty heavy right now on this part. is the derivative of the first times the original second plus derivative of the second times the original first. Now it wants us to find h prime of 3. So I'm going to plug in 3 for all of my x values. Okay? Again, I think the easier of the two is the ones that are not the derivatives. So if you look at g of 3, I'm going to find this one first. G of 3 is going to be right here. I'll try to color code this for your brain. So g of 3 is right there, which is 3. Then I'll use blue for f of 3. So f of 3 is going to be 4. Now here's where it gets a little tricky. I'll use green for the slope here. But f prime of 3, remember, that's going to be the slope when x is 3. So actually, the tangent slope of the tangent line, I should say, the tangent line is actually the line f of x. So if I can find the slope of the f of x line, that's going to give me my value for f prime of 3. So the slope looks like it's up 1, left 1, right? Up 1, left 1 is going to be a negative 1. Now, doing the same thing, I'll use orange for the g of x function at 3. We'll notice that we have a slope that's a positive slope and a little steeper. So I find the slope of this piece of the piecewise function, that's up 1, right 2, right? Up 1, right 2. So my slope is going to be positive 2. So if I go ahead and deal with this algebra, I can find what h prime of 3 is equal to. So negative 3 plus 8, which is positive 5. That's number 26. Let's keep going to number 27. It says we have f is a differentiable function such that f of 3 is 4 and f prime of 3 is 5. If g of x is x squared times f of x, what's the value of g prime of 3? So the first thing I'm going to do is to find the derivative of g of x. Again, another product rule. So I have to find the derivative, show a little work here, the derivative of x squared times the original second plus the derivative of f of x times the original first. Well, the derivative of x squared is 2x, and the derivative of f of x is f prime of x. And now I'm able to plug in my x value of 3. So wherever I see x, I'm going to put 3. And then I'm going to use the information in the problem to finish this. So that's 6 times f of 3, they said, is 4, plus f prime of 3 is 5 times 9. So 24 plus 45 is going to be, letter D, 69. There is 27. 28. 28 is another one where you'll have to use the derivative of your, this one here, your natural exponential function, right, which we talked about a few problems ago. So that means I'm going to do, this is a product rule, so I have d dx of e to the power of x times the sine of x plus d dx of sine of x times e to the power of x. So using the formula sheet, the derivative of the natural exponential function is you copy e to the x, whatever it is, times the derivative of whatever's in the power, and the derivative of x is just 1, times the sine of x, plus the derivative of sine of x is the cosine of x times e to the x. So if I clean it up, I get e to the x times sine of x plus e to the x times cosine of x. So that's the answer. You'll notice you don't see that in your answer choices because they have factored out an e to the power of x. So if you factor that out, you'll find an answer is C. That's 28. Remember again, on purpose, I did not do that last lesson in chapter 3, all right, because I knew that we could just get to the review and you could use the formula sheet to figure out the derivatives of those exponential and logarithmic functions. All right, let's try 29. 29 says to find the derivative of y, right? Y prime means to find the derivative. This is going to be an example of the product rule, and we're going to have some chain rule. But what I want to do first is I'm going to actually rewrite y to be x times 2x plus 5 to the 1/2 power. So the reason I do that is because then it's easier for me to use the power property. So here's the derivative for y. So it's d dx of x times 2x plus 5 to the 1/2 power plus the derivative of 2x plus 5 to the 1/2 power times, not 1/2 power, or yes, it is 1/2 power. I said 1/2, but I wrote 5, times the original x. All right, we know the derivative of x is 1, so this just becomes 2x plus 5 to the 1/2 power plus, now here we have the power rule, so 1/2 times 2x plus 5. Subtracting 1 from 1/2, I get negative 1/2. And remember, we need the chain rule. All right, the derivative of 2x plus 5 is 2, and then times the original x. So I'm going to rewrite this with the radicals because I look at all my answer choices, and all my answer choices have that back as a square root. So I'm going to put it back in a square root. So the square root of 2x plus 5 plus, now watch what happens here. We have a 1/2 at the beginning, and we have a number 2. All right, half of 2 is just 1. So this is going to become x over the square root of 2x plus 5. Now this is the answer, but you'll notice none of my answer choices are matching this. So I need to add these two fractions together. So I'm going to get a common denominator and multiply this one by the square root of 2x plus 5 over the square root of 2x plus 5. So some algebra happening here, right? This is definitely no longer calculus. So when you multiply with radicals, the radical goes away. All right, so now I have a common denominator. I can add those together, at least I can add the tops together and get 3x plus 5 over the square root of 2x plus 5, which is letter A. Number 30. Number 30 is going to be a combination of the product rule and some chain rule. So I'm going to find f prime of x by doing the derivative of x minus 1 squared, then times the original second, plus the derivative of sine of x times the original first. The derivative of x minus 1 squared, we're going to use the power rule, 2 times x minus 1 to the first power, times the derivative of x minus 1, which is just 1, plus derivative of sine x is cosine x times x minus 1 squared. So if you want to clean it up, we have 2 times x minus 1 times the sine of x plus x minus 1 squared times the cosine of x. This is the derivative. Now, it doesn't want that. It wants what happens when you plug in 0 into the derivative. So everywhere I see x, I'm going to replace with 0. Okay, so we have 2 times negative 1 times the sine of 0. Again, if you need to use the trig formula sheet, I gave you guys one recently. You can always refer to the quadrantals. I know that the sine of 0 is 0. All right, plus 0 minus 1 is negative 1 squared is positive 1 times the cosine of 0 is 1. So all of that is going to be 0 plus 1, which is 1. That is number 30. 31. All right, we're going to find the derivative in number 31. And again, I'm going to rewrite y first. I'm going to rewrite y first to be 5x times x squared plus 1 to the 1/2 power. So I can use the power rule when I get to it. So dy dx, or y prime, is the derivative of 5x times x squared plus 1 to the 1/2 power plus the derivative of x squared plus 1 to 1/2 power times the original first one, which is 5x. All right, so the derivative of 5x is 5 plus the derivative of this. I need to use my power rule, so 1/2 times x squared plus 1 to the negative 1/2 power. Then chain rule, the derivative of x squared plus 1 is 2x times 5x. So this is going to be 5 over the square root of x squared plus 1. I don't know why I put that over. Sorry, let me try again. That one's not the negative one. So 5 times the square root of x plus 1. That's better. Plus, again, like before, the 1/2 and the 2 are going to cross out. That's going to leave me with 5x squared over the square root of x squared plus 1. Now, if you wanted to, you could get a common denominator like we did a couple problems ago, but I'm not going to. I'm just going to plug in because they want me to evaluate it at x equals 3. So I'm just going to plug in my y prime at 3. So it's going to be 5 times 3 squared plus 1 plus 5 times 3 squared over the square root of 3 squared plus 1. So 3 squared is 9, 9 plus 1 is 10, so that's 5 times the square root of 10 plus 3 squared is 9, 9 times 5 is 45 over the square root of 10. So I'm looking for this answer, and look at all my answer choices. The only one that matches up is letter D. All right, that is 31. Let's move on to 32. All right, so 32 gives us these two lines, and we're trying to evaluate h of x when x is 2. And again, like a couple that we've already done in this part, h of x is the product of two functions. So let's find the derivative of h of x. Remember, using your formula sheet, you get f prime of x times g of x plus g prime of x times f of x. So I'm going to plug in 2 wherever I see x. And I'll try to use my color coding again to see if that helps you understand where I'm getting all of this. So I'll start with g of 2, all right, for this one. So g of 2 is going to be positive 1. Then I'll use blue for f of 2. F of 2 looks like is going to, oh, that's not 2. F of 2, my bad. F of 2 is going to be 3. Now for these other ones, the derivatives, we have to look at the tangent lines at these points. So for f prime at positive 2, the slope is actually going to be this for this tangent line in green, and it actually is the line f of x. So I just got to find the slope of f of x, which is up 1, right 2, right? Up 1, right 2. So that's going to be a slope of 1/2. And that's the y value then. And I'll change back to orange for g prime of 2. So here is the tangent line there, which is a negative, and that's up 1 to left 1. So up to left 1. So it's a negative 2. All right, so if I do the algebra here, I'll be able to get my answer for h prime of 2. So that's 1/2 minus 6. Change it into a common denominator. That's 1/2 minus 12/2. And 1/2 minus 12/2 is negative 11/2. And that's it. So that's number 32. Let's go to 33. Now 33 is asking us to find the derivative of 2x plus 3 over 3x plus 2. So I'm actually going to use the quotient rule here. Go to the formula sheet if you need to, right? And you can find the quotient rule here that gives you the formula. So I'm going to write down the derivative here is going to be for y prime is d dx of the numerator times the original denominator minus the derivative of the denominator times the original numerator, all over the denominator squared. Okay, the derivative of 2x plus 3 is just 2. And the derivative of 3x plus 2 is 3. All over the denominator squared. Distribute, you get 6x plus 4. I'm going to distribute the negative with the 3. So at the same time, gives you negative 6x minus 9. Keep writing that denominator. And now you should notice that your 6x and your minus 6x are going to make 0. So my numerator is just going to be 4 minus 9, which is negative 5. All right, so my answer is going to be D. 34. All right, very similar problem to what we just did. I'm going to use the quotient rule again. All right, I thought about what could happen if I factored. But if you factor the numerator, there's nothing that can cross out, so no reason to factor. Just use your quotient rule, which is the derivative of the numerator times the original denominator minus the derivative of the denominator times the original numerator all over the denominator squared. All right, the derivative of the numerator is going to be 2x plus 3 times the original denominator minus the derivative of x plus 3 is just 1 all over denominator squared. Distribute, 2x times x is 2x squared, 2x times 3 is 6x, 3 times x is 3x, that gives you 9x plus 9 minus, I'm going to distribute the negative with the 1, minus x squared minus 3x and minus 2. Okay, let's get like terms in the top. 2x squared minus x squared is 1x squared. 9x plus negative 3x is 6x. And 9 plus negative 2 is 7. So I'm looking for this for my derivative, which is letter C. That one is 34. Almost there. Let's go to 35. Now 35 says we have the values for two differentiable functions f and g and their derivatives at x equals 0. So if it gives us h of x equals 6 times f of x divided by g of x minus 1, then find h prime of 0. So let's first find h prime of x using our quotient rule. All right, and I'm actually going to be using, pointed out to you, the constant multiple rule, which is the very first one up here, because I have a 6 in front of it. So I can actually just write 6 times the derivative of f of x. That's called the constant multiple rule. Times the original denominator minus the derivative of the denominator, which is g dx of g of x minus 1 times the original numerator all over the denominator squared. Okay, let's do some derivatives here. So 6 times the derivative of f of x, which is just going to be f prime of x, times g of x minus 1, minus the derivative of g of x is going to be g prime of x, and the derivative of negative 1 is just 0, so that's just going to go away, times 6 times f of x, all over the denominator squared. Okay, so that's h prime of x. Now I'm going to plug in 0 wherever I see x, and I'm going to use that table. So 6 times f prime of 0 times g of 0 minus 1 minus g prime of 0 times 6 times f of 0 all over g of 0 minus 1, all of that squared. All right, so now I'm going to plug in numbers. So I've got 6 times f prime of 0 is 1/2 times g of 0, which is -2 minus 1, which is -3, minus g prime of 0 is 3/2 times 6 times f of 0, which is 4. All right, and that's all divided by, try that one again, all divided by g of 0, which is -2 minus 1, which is -3 squared. All right, I'm going to move over here to finish it. Half of 6 is 3, so that's -9, minus 6 times 3/2 is going to be 9. 6 times 3 is 18, divided by 2 is 9. 9 times 4 is 36, all over -3 squared, which is 9. That's -45 divided by 9, which is -5. The answer is D. All right, so that's 35. 5 more to go. 36. So we want an equation of the line that's tangent to the graph of this y equation going through the point 1,5. So the moment you read this, you should be thinking, I'm going to need point slope form right here. So I need a point, which they gave us both the x and y value for the point. They gave us 1, 5. So I need to find the derivative of y, so y prime, which is going to be d dx of the numerator times the original denominator minus the derivative of the denominator times the original numerator all over the denominator squared. Okay, the derivative of 2x plus 3 is just 2. The derivative of 3x minus 2 is just 3. All over the denominator squared. So 2 times 3x minus 2 is 6x minus 4. Distribute the negative with the 3. Minus 6x minus 9. Okay? And then to finish this, that's going to be -13 over 3x minus 2 squared. So that's the derivative. But I don't just want the derivative. I need to evaluate the derivative at my x value for my point, which is 1. So I'm going to do y prime of 1, which is -13 over 3 times 1 minus 2 squared. So 3 times 1 is 3. 3 minus 2 is 1. 1 squared is 1. So -13 over 1, or -13 is the slope. Now we're ready for point slope form. So I'm going to do y minus 5 equals -13 times x minus 1. Distribute the -13. So y equals -13x. And then if I move the 5 over with, or -5 over with addition, I get plus 18. So I'm looking for this answer. And you'll notice the answer choices for 36 don't look like that. But the one that matches with it, because these are in standard form, is going to be letter B. Because if I move that 13x over, it would become -13x plus 18. All right, 37. All right, now 37 is implicit differentiation. So we're going to go over this in class actually today. But so far, right, until your lesson on implicit differentiation, everything we've taken the derivative of has been expressed fully in terms of x on the right-hand side or the left-hand side. So like y equals 2x plus 6, y equals sine of x times 4x squared, whatever. It's always been just one y on one side of the equation, everything else with x on the other. That is called explicit because your y is being explained explicitly by x, okay? The reason that implicit differentiation exists is because, like, if you look at number 37, you'll notice we have our y and our x on the same side. All right, so I'm going to take the derivative of all of these terms. All right, and this will be a little simpler after you have watched the lesson on implicit differentiation. So to find dy dx, I'm going to do d dx of 3x minus dy dx of, let me do it like this. So d dx of tangent of y equals d dx of 4. So you're taking the derivative of all three pieces. Two of them will make more sense to you. The derivative of 3x is just 3. Now watch how I do this. The derivative of tangent of y is secant squared y. But because my argument is not an x, I have to then write dy dx. So that's actually going to be what we end up solving for. And the derivative of a constant, is 0. So I'm going to move this over to get secant squared y times dy dx. And if I want to solve, right, I'm solving for dy dx, I'm going to divide both sides by the secant squared of y. Okay, so my answer, even though it won't be the answer on these multiple choice on this question, we'll have to do a little bit more work, is 3 over secant squared y. The reason you don't see it is because of your understanding, hopefully, that secant squared and cosine, or I should say secant and cosine, are reciprocals. So if I see secant in the bottom, I can rewrite this and move it as cosine in the other one, in the top. So like if this had said secant squared in the top, I could put cosine squared in the bottom. So the answer that you'll see is actually 3 times cosine squared y. And if you need to refer to your trig formula sheet, I can always pull that up for you and show you what I'm talking about. So if you look here, what I'm basically saying is that what I understand that secant and cosine are reciprocals. So if I see secant squared in the denominator, I can write cosine squared in the numerator. If I see secant squared in the numerator, then I can write cosine squared in the denominator. So it's always vice versa there. All right. So that's why the answer is B. All right, number 38. We're so close, 3 more. The derivative of cosine x times tangent x. So this would be, since this is a product, we're going to do the derivative of cosine first times tangent plus the derivative of tangent times cosine of x. The derivative of cosine x is the opposite of the sine of x, so times tangent of x, plus the derivative of tangent is secant squared x times cosine x. So this is the answer. Now you notice you don't see it. All right, here's where the fun begins. I'm going to use my trig formula sheet to show that negative sine of x over 1 can multiply by tangent of x, which I can rewrite as the sine of x over the cosine of x, plus, right, if I move the secant squared to be cosine squared, I get cosine of x over cosine squared x. So that's negative sine squared x over cosine x plus, you'll notice this is just going to be 1 over cosine x. I've got a common denominator, so I'm going to add my numerators. Still, this isn't the answer, right? We're getting closer, all right? But I'm going to use my Pythagorean theorem, or one of my Pythagorean trig identities. Let me show you over here, right? Remember this one? Sine squared x plus cosine squared x equals 1. And if I move sine over to the other side, I get 1 minus cosine squared, 1 minus sine squared x equals cosine squared x. So I can replace this numerator, which is the same, just kind of a different order. The sine squared is negative, the 1 is positive. I can replace the numerator with cosine squared. And cosine squared x divided by cosine x is just 1 cosine x. So all of that, wow, all of that became just cosine of x. All right, again, I put this on the review because the majority of this problem felt a little bit unfair to put on the actual test because you needed to use so much trig, which was last year. So I put it on the review, not to say that there won't be trig on the test, but I felt like this was just a little bit too unfair. since you had to use a couple of trig identities. Okay, two more. 39. We're going to do the power rule and the chain rule. So watch this. You're going to do 5 times x over x plus 1 to the 4th power. But then we need to do the derivative of the inside. So that's going to be the derivative of the numerator times the original denominator minus the derivative of the denominator times the original numerator all over the denominator squared. Wow, that's a lot. So here we go. This is going to keep being 5 times x over x plus 1 to the fourth power for the time being, times the derivative of x is 1. So that's just going to be 1 times x plus 1 minus derivative of x plus 1 is also just 1 times x over x plus 1 squared. Watch what I do with the left side here. So 5 times x to the 4th power over x plus 1 to the 4th power. So I gave each the numerator and the denominator that 4th power. Times, this is going to be x plus 1 minus x over x plus 1 squared. Keep doing it. I'm going to move that 5 to be in the top. Okay, and then times x minus x is just 1 over x plus 1 squared. So if I multiply straight across, I'll get 5x to the 4th power over, now watch this, they have the same base, if you will, x plus 1. So I'm going to do x plus 1, and there's now 6 of them. So that's going to tell me that the answer for 39 is D. Okay, last question, then we'll be done with part 2. Stay tuned for part 3. All right, so last one. We have y equals x cubed plus 1, all of that squared. So find dy dx. So power rule here first. 2 times x cubed plus 1 to the 1st power times, here's the chain rule. The derivative of x cubed plus 1 is going to be 3x squared. Clean it up, you get 6x squared times x cubed plus 1, which is going to be E. And that's it. I'm going to stop here for part 2. Don't forget, I will be doing a part 3 for the last 20 questions.